So you have three different equations of a line, though. Um, the equations of the line, you have point slope form, which is, where y1, m, and x1 would normally be numbers. You have slope intercept form, which is the most popular way because it's also in what we call function notation, where y is a function of x. But really, what's happening here is these two values would normally be numbers. The y and the x would stay where they are. And you have this form down here where the a, the b, and the c. They call this general form. Sometimes they call it expanded form in different textbooks. What's good about these two is that, you have plenty of information about the line just based on looking at the equation. So the information is easy to see. Whereas in general form, it's not really easy to see. You'd have to do some kind of either mental calculation or work it out on paper to figure out what the actual equation of the line is. So, but even though this is the form that's usually most often sought, a lot of people overlook this because a lot of times you might have a situation where this is much easier to get than the slope-intercept form, and you could get the equation of a line really easily. And even if you don't need that format, they want it in slope-intercept form, it's pretty easy to convert point slope into slope-intercept. So let's go back and show you. Now, as we go through these next examples, we've already done some of the work on this because we found the slopes of them back in example 1. So I'm not going to go to a bunch of hardship here and say, okay, m equals negative 10/3 for this one, m equals 1 for this one, m equaled 0 for this one, and m equaled undefined here. But for the sake of argument, I'm going to also remember it as the 5/0 that we found it to be, for reasons I'm going to get into momentarily. Because what I'm going to do now is I'm going to use point slope for A, which means I'm going to pick one of the points. It doesn't matter which one I pick. So I'm just going to pick the 4, 6. And according to point slope form, y minus this y coordinate would be y1. So 6 equals negative 10/3 times x minus x1. X1 would be the x coordinate of that point, so 4. So this is the point slope form. If I wanted to put this into slope intercept, it wouldn't take much more effort. I would first have to simplify the right hand side. And then I'm going to add 6 to both sides. So basically, I want to get y by itself, essentially. So negative 10/3 x plus 40/3 plus 18/3, because that's what 6 is. I'm adding 6 to both sides. And so y equals negative 10/3 x plus 58/3 is the equation of the line in slope intercept. Excuse me. So, that's not a big deal. To convert one to the other. Okay. Now, I could just, for B, I'm going to show how to do it using just starting with the y equals mx plus b. Basically, it's kind of a different handling. Whereas I just mostly plug numbers in to get point slope and then just manipulate it. Here, if I want to find it in slope-intercept form, well, I know that m is 1. And usually if I have a coefficient of 1, I don't write the 1. What I'm going to do is I'm still going to pick one point, and I'll pick the first one. That's what I'm going to do for all of them. When I pick the first one, I'm just going to substitute it in for what they are. This is an x-coordinate. This is a y-coordinate. So negative 1 is what y equals when x equals negative 6. So to solve this, I have to add 6 to both sides, and I get that b is 5. So my equation in slope-intercept form is y equals x plus 5. Slope-intercept. So, I mean, you could go right to slope-intercept. You just have to know how to what you need to do with the coordinates in both cases. Point slope, it's pretty much, okay, insert it where it needs to go. Same thing with slope slope-intercept, but you always have to make sure when you go back to the equation, you have the y and the x there. I'll have students who'll write a statement like -1 equals -6 plus 5 and say that's the equation of the line. It isn't. The equation of a line has an x and a y in it. That just calculated one coordinate for that line. Now C was our horizontal line, which had a slope of 0. So if I try to treat it the same way as I did the previous one, y equals 0x plus b, and I'm solving for b. Notice I'm keeping the 0 there for no apparent reason, but I'm going to just use the first point. So, okay, 7 equals 0 times 4 plus b. Well, 0 times 4 is what b is. So if I do y equals 0x plus 7, well, 0 times x is nothing. So it's just y equals 7. And so when you look at the equation of a line, if it just says y equals a number, it's a horizontal line, and it means that all the y coordinates are that number. In this case, is 7. Much the same with D. Here's why I kept the slope as 5 over 0, because that's the undefined value. Again, if I start doing the same thing, I say, okay, y equals 5 over 0x plus b. I want to solve for, I'm going to use 6, -2, so -2 equals 5 over 0 times 6 plus b. When I subtract b from both sides, it's kind of a more complicated equation. What ends up happening is I multiply by the 0, and I end up with 0 over here equals 5 times 6, which, that doesn't make any sense. It's not going to be solved in this way. That's because of the undefined slope. But basically the reason why it's happening is because of the fact that my x's canceled each other out. Much like when you look at here, you see, okay, well, I have a common y. That means it's a horizontal line, and the y's are always 7. I kind of look at this the same way and say, well, they have a common x, and the x's are always 6. So x equals 6 would be the equation of a vertical line. A lot of the stuff we were doing with the other ones, trying to put it into a function form wasn't working because this isn't a function. It's a vertical line. It fails the vertical line test. I mean, it sounds kind of weird. The vertical line fails the vertical line test, but that's exactly what it does. So, to kind of summarize, and I didn't want that to appear like that. There we go. So basically, to sum it up, a vertical line always has the form x equals some number. Horizontal line always has y equals some number. And the point slope form, slope intercept form, and general form are ones that we've already talked about. So now, one of the things about expanded form, which is what these in, or expanded form, general form, whichever you want to call it, is that, unlike the other two, if I look at the equation of a line in point slope form, I could tell you what the slope is, I could tell you what a point the line passes through is, and from there I could draw the line. For slope intercept form, I could tell you the slope, I could tell you what the y-intercept is, which is another point that's on the line, and if I have that information, I can draw the line. These don't tell you anything. The only way to possibly get any information out of this is either to plug numbers in and get some coordinates, or to actually do what they're asking you to do here, to put it in slope-intercept form, which is what I'm going to do, since it's what's asking me. And all I like to do is, to put it in slope-intercept form, don't make it more than it is. It just basically means solve for y. means get y alone. So on the left, I'm going to subtract 2x from both sides to get 4y equals negative 2x plus 14. I'm choosing to write it that way because I know that when I write the equation of a line, it usually, in slope-intercept form, it starts with some number times x. So I want x in the first position. And I'm going to divide both sides by 4. I have to keep in mind that when I do this, I'm dividing this entire quantity by 4, and there's 2 terms in it. And division gets distributed much like, multiplication does. So negative 2 divided by 4 is a negative 1/2 x. 14 divided by 4 is the same thing as 7/2, so you can write it as 3.5 if you want. But there you have it. For B, I'm going to add 24 and subtract 5x from both sides. So 5x was subtracted, 24 was added. I'm going to divide both sides by 8. I get negative 5/8 x. And remember again, since I'm dividing both sides by 8, it gets distributed. So 24 divided by 8 is 3. So pretty straightforward with that.